This is Daniel Coosbury, and this is the first video in a section, a group of videos on descriptive statistics. So as we talked earlier, the goal of statistics is you've got this population that you're interested in, and I know I've drawn this picture a few times, and inside the population, you're going to draw yourself a sample and use what's going on in this sample to describe the population. So a lot of what we're going to look at in the next few videos is going to be ways we can learn things about the sample itself, and there's some things we can learn about the population if we know all of it. But we're going to learn how to compute some things or find some important things about the sample so that we can later use those things to make inference about what's going on with the population itself. So when I say descriptive statistics, I'm referring to statistics that talk about the sample and just the sample. This isn't complete because we are going to look at some parameter things too, but most of what we're looking at is going to be statistics. So let's start with the mean. The mean came a data set kind of came from this idea of wanting to find the center of the data. And so, for instance, like in this data set, this is the vehicle emission data set. We might wonder, once we've like visually represented this data and we can kind of see what it looks like, and there's this high thing here, a question that we're often interested in answering is, what is the center or the middle of the data set? And what do we mean by that? But like how do we summarize what's going on with all the things? Like what's the middle? Is it this biggest thing here, or is it right there? How do you find the middle? How do you like define the middle? And oftentimes, usually we come to the conclusion that the mean is a really good way of describing the center or the middle of the data set. And what we mean by mean is the average, the arithmetic average of the data set. So we're going to look just at the mean, and then in another video we'll look at other kinds of ways of talking about the center that can be good or useful in a good context. But the mean is probably the most mathematically complex one to compute, so we'll spend a whole video just on that. Okay. We have two different kinds of means. We got the population mean and the sample mean. So remember, we're dealing with, in one context, we're dealing with, I lost my pointer. We're dealing with the big box population. In another context, we're dealing with the little circle sample. So this is my picture again to show you what we're talking about. So the population mean is this big box, is going to come from this big box. The sample mean is going to come from this little sample in here. But they're computed the exact same way. Let me talk real quick about notation. The population mean is denoted by this Greek letter mu. Mu is the letter for m, so we use it for mean, mu, m. And we find mu by adding up all these x values. So this xi just represents all the data values. So if we have like 5 pieces of data, we might call them x1, x2, x3, 3, x4, and x5 maybe. We just kind of give them those kind of names. The I is just a general like letter that represents any number of things. So we could have 200 of these. We can go to x200. Xi just lets us write that without listing them all out. So this represents all the data values. This big capital sigma means sum. So sigma is the capital letter, is the Greek capital letter for S. It means, it stands for sum. So we're going to add up all the data values. That's what this means. Add up all the data values. Say it with me. Add up all the data values. So we're going to add up all the data values, and then we're going to divide by n, which is going to refer to the population size. When you see capital N in statistics, it's referring to the population size. How many things are there? So if the population were the 50 states in the United States of America, then n would be 50. And then we'd have 50 x values to add up. So add up the 50 things and divide by 50. That's how you find the population mean. You probably knew that, but this is some statistical notation to give so that you know what you're looking at when we do some problems. The sample mean is found the exact same way. It's just found with a sample instead of in the big population. So you imagine you don't have the whole population. You'll just take a sample. These refer to all the things in your sample. This is your sample size. This means add up all the things in your sample. So you find the sample mean. There's the sample mean, x bar. Add up all the things in your sample, and then divide by the sample size, just like with the population. So the nice thing is these formulas are basically telling you the same thing. They're just in two different contexts, which is why you have different symbols going on. So this is a real simple example. We have five students took 5 exams during the semester. So this is one student taking 5 exams. So we're going to treat his exams, the total of his exams, like a population. So all of their exams, 1, 2, 3, 4, 5, we have them all. It's a population. So we can find the population mean using this formula. And this is just what this formula looks like when you put numbers to it. Add up all the things, 1, 2, 3, 4, 5, and then divide by the population size. So this ends up being 406 over 5, or 800, or 81.2. Note that usually when we do this, if we have data that's not rounded to any decimal place, we usually add a decimal if we need to. The rule of thumb here is if you need to add one more decimal place than the data has, that's what you'll do for rounding the mean. Let me stop real quick and show you how I would do this in a calculator. So usually when you're dealing with data, you're not dealing with 5 data points, you're dealing with a lot more than that. So I went ahead and put this data in my TI-84 calculator, and I'm going to go to Stat Edit to show you where I did that. So here's the 5 scores right here in L1. So once I have this data here, I'm going to get out of this screen by hitting second quit. So you want to get out of here, second quit, second mode, second quit. So I'm out of there. I'm going to hit Stat again, and then go over to the Calc Catalog. So use the right arrow key to go over to the Calc Catalog. So Stat, right arrow. And then in the Calc Catalog, I want to use one variable stats. Now we're going to end up using this one command an awful lot in this class. This is going to give us a lot of summary information about data sets. So I'm going to click on that. I want to tell it that my list is L1. This is my data. And my frequency list is nothing at all. I want to make sure there's nothing there. So if there's something there, delete it. My list is L1, and then there's nothing in my frequency list. Now, if you're looking at a TI-83, you should see one variable stat on the home screen. Just type in L1 next to it. Use a second one. Use that little blue L1 right there, second one, and you'll get the same. You'll get the same result. So now I'm going to hit Enter on Calculate, and there is my sample mean. So there's X bar, same number. So it went ahead and found it for me. It found a lot of other things, including the sample size, which usually you know, but if you didn't, there it is. So with a bigger data set, I would suggest doing this every time because you're likely to mess up this when you add a bunch of numbers. The calculator won't mess up. So punch the numbers in the calculator correctly, check that you did it right, and then let the calculator find the mean. It's worth noting, yeah, this is called X bar, that's mu. They have the exact same formula, so we'll treat that as the population mean. I might have misspoke, not the sample mean, it's the population mean. But it's the same thing. You use the same formula. Okay, so let's look at group data. So sometimes you either don't have access to a whole data set or you just see a summary and it's more convenient to work for a summary. So this is a sample of 50 high school students and the number of text messages they send. And I don't know what the time frame is, but yeah, they send text messages. And rather than seeing all 50 data points, this data comes already grouped. So the class width is 50, you can see that. You can see the biggest class and the smallest class. And we want to compute the mean number of text messages sent, but we don't have all 50 data points. So we can't just add up 50 things and divide by 50. We do have another method that is kind of nice, and it's using this formula down here. So we're going to end up using the class midpoints, which I think we used to make histograms on a previous video. But remember, to find the class midpoints, you want to take the lower limit of one class and the next lower limit, and the midpoint's going to be what you get when you add it up and divide by 2. So the first midpoint's going to be 25. The next one is going to be what you get when you add up 50 and 100, and then divide by 2, you get 75. So you want to get the midpoint of each class. This seems to be the right midpoint here. This seems to be right too, so that works out. And you'll find all the midpoints. And then you need the frequencies which are given to you. And what this formula means here, so there's the add it all up thing. But see how this is in parentheses? This means that you want to take each midpoint and multiply it by its related frequency. And you want to do that over and over again before you ever start adding things. So you want to do this multiplication first and then add. I'll show you on the next slide. So we said we want to do find the midpoints. So there's all the class midpoints. These are the frequencies from the last slide. And the formula said do the multiplication first. So I'm going to multiply these two numbers together, and then these two numbers together, and these two. And that's how I got this column on the far right. So you just keep doing that, and you get this column right here. So that's the midpoint times the frequency. And you would just do that each time. This is called pairwise multiplication. So you pair them up and multiply them before you ever add. And then you add them all up, and you end up with 6,850. So once you do the pairwise multiplication, you get them in this column, add them all up, and you get the sum of the multiples of things. Then you divide it by 50, and you end up with an approximated mean of 173. So that's scary, and that's messy. And frankly, I would, unless I had no choice, I wouldn't do this by hand. I would do it using the TI calculator. So this is a really nice method. It gives you an approximated sample mean. It's maybe not necessarily the actual mean, but it's supposed to be your best guess. But I would still do this on the calculator. So with the calculator, we're just going to, we want to make lists of these two things right here. So we want to make one list of class midpoints, one list of frequencies, and then we're going to do that one variable stats trick again. So let me pull my calculator back up. I've taken the liberty of entering this in the calculator already. So you can see in my lists, I have the class midpoints here under L2, and the frequencies are here under L3. So this is my midpoints, this is my frequency. So now I'm going to get out of here. I'm going to go back to stat calc, to that one variable stat button. So I'm back in one variable stats. Now I got two lists. I need to put them both in here. So my first list is going to be the class list. It's the midpoint list. So I'm going to make sure that says L2. So I'll do second 2, I get L2. And then for the frequency list, now I have a frequency list. So this is easy to remember. The frequency list is the frequency, which I saved in L3. So my list is L2. My frequency list is L3. So then, once you do this, you want to hit calculate. And I'll show you TI-83 folks what your screen's going to look like in just a sec. But you see how once I do that, I get my approximated mean. So I don't have to do all this stuff by hand. I just let my calculator do it. Now let me show you what your TI-83 people need to do. So when you hit one variable stats, you have this on your home screen. Then what you need to type in next is L2, so hit second 2. Then type the comma, which I believe is right here, and then type L3. So you're going to do your class midpoint, comma, frequency list. And then once you hit enter, you get the exact same thing. You get the 137. So that's how you're going to approximate the mean using grouped data. And it's an approximation, but it's the best one you can get. Okay, the last thing I'm going to show you is how to do a weighted mean. So for a weighted mean, you're going to give your data values different weights. So some things are going to count more than others. So oftentimes when we're doing like a GPA, some grades count more than others. So grades that are an A count something like 4.0. Grades that are a B count something like 3.0, and so on and so on. So your grades get a special weight, all of their own, that end up affecting your mean. So this is your formula for a weighted mean. You've got your weights represented by W. So each X, this is important, I guess, to say, each XI has a specific weight. So data point number 1 has a special weight called W1, and so on and so on. What you want to do, you want to multiply your weights times your data values, then add them all up, and then divide by the sum of your weights. So here's an example. We have Joe, who took 4 courses. He got an A in statistics, which gave him, it's 5 credit hours. He got a B in psychology, which is 4 credit hours, a C in English, which is 3 credit hours, an A in music, which is 2 credit hours. And then this gives you the worth of the A, the B, the C, and the D. So these end up showing you the A's and B's and C's and D's are worth different things. So we're going to treat the A worth as 1 weight. So each A is going to be worth 4. So that's 1 weight. Each B is going to be worth 3. Each C is 2. And then we're going to add up the credit hours times the weight. So this is going to be your X1, your X2, your X3, and your X4. So the 5, this is your X, here, let me kind of, I need to label this down here. So your 5 is going to be X1. So this is X1. Oh man, the pen's not working. X1. Whereas you're going to put that with this weight. Your 4 here is going to be X2. And that goes with the B weight. So there's a 3 there for B. And then your 3 credit class is going to be your X3. And your 2 credit class is going to be X4. Something weird is going on here. But you see how the numbers in parentheses correspond to how much your grade is actually worth. So this is a 4 for A, a 3 for B, a 2 for C, and a 4 for the A that he got in music. Whereas these numbers represent the credit hours. So 5 credit hours, 4 credit hours, 3 credit hours, 2 credit hours. And then you're going to add up all of your credit hours down here. And suddenly you have your weighted mean. So you're going to take the X's times the W's and then add up the W's. And that's how you do it. Weighted means are a little frustrating. There may be a nice trick to do it in the calculator, but frankly, I think they're a little confusing, and I would rather just write it out by hand and do the multiplication and addition so that I know that like things are where they're supposed to go. Anyway, weighted means don't come up too often, but it is possible to do and use a formula like that. So that's a few different kinds of ways of computing the mean.